Welcome back. Today we are doing our arrangement of cells under physics. The last time we did arrangement of resistors, but today we are doing arrangement of cells. As you can see, there are two ways that we can arrange cells. The first way is cells in series. When cells are arranged in series, it's like cells are arranged on a straight line, as you can see now. Here we have E1, E2, and E3. R1, R2, and R3. Here we have the total EMF. Total EMF E of cells in C series is what? E1 plus E2 plus E3. And the total internal resistance, small r, is equal to R1 plus R2 plus R3. This is the first method of this is under cells in series, where nothing is equal. The EMF is not equal and the total internal resistance is not equal either. So the second method, the second way we can arrange cells is cells in parallel. We have E1 R1, E2 R2, and E3 R3. As you can see here, under cells in parallel, the total EMF E is equal to E1 is equal to E2 and is equal to E3. And then the total internal resistance R is equal to 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is all under our arrangement of cells. Now we can move to current in a circuit. Current in a circuit is when we have a cell or more than one cell with a resistor or more than one resistor. As you can see now, here we have a cell, and here we have a resistor. Here we have the current I. Here we have the EMF and the internal resistance. Here we have the external resistance. And in the current in a circuit, the current is equal to electromotive force over the total resistance. Electromotive force over the total resistance. That is I is equal to EMF over R plus R, where I is equal to the current in ampere. A. EMF is equal to the electromotive force R, the big R, is equal to the external resistance. and the small r is equal to the internal resistance of the cell. That is I is equal to E over R plus R. That is the current is equal to the electromotive force over the external resistance plus the internal resistance. And when we cross multiply here, E is equal to the current I into the external resistance plus the internal resistance. Then E is equal to I R plus I small r. But V is equal to IR, that is from Ohm's law. From Ohm's law, V is equal to IR. E, no, that is V is equal to the I big R. That is this one. That it means this one is also the same as V. This E is equal to V plus I small r, where V is the potential difference across big R and E is the EMF of the cell. Now this is all under current in the circuit. Now we can move to efficiency of a cell. Efficiency of a cell. Now efficiency is equal to V over E multiplied by 100%. This is the same as IR over I into R plus small r into big R plus small r times 100%. And that is also equal to, and then like that, when this I cancels this I, it remains R over R big R plus small r. That's big R over big R plus small r times 100%. So this is the formula for calculating the efficiency of a cell. You can use any. You can use this. You can use this, or you can use this. You can use IR over I into R plus R times 100%. You can use any, except for this one. You can use any, but this one will take time. This one is the short one of this one. So then now, example now. A cell of EMF 1.5 volts and internal resistance 1 ohm is connected to two resistances of 2 ohms and 3 ohms. Calculate the AI current in the circuit if the resistances are connected in series. If the resistances are connected in series. The second one under E, the potential difference across the 2 ohms resistor. The BI now, the current in the circuit if the resistors are connected in parallel. And the last one, the current in the 2 ohms resistor. This is the example. And then now, solution. Now solution. Let's draw the diagram first. We will draw the diagram first. That is a cell coming down. Remember, there are two resistors in the question. This is resistor A and resistor B. This is 2 ohms and this is 3 ohms. And this is the potential difference across A. That is across the 2 ohms resistor. And now here we have E as 1.5 volts and internal resistance as 1 ohm. The AI part now. The current I in the circuit, that is I is equal to EMF over R plus R. Sorry, that over big R plus small r. And the big R is equal to the RA plus RB. That is RA plus RB. The resistor A plus the resistor B. That is R is equal to 2 ohms plus 3 ohms, which is 5 ohms. That is the external resistance. R is the external resistance. R is equal to 5 ohms. And the internal resistance, small r, is equal to 1 ohm. And now I, that is equal to E over big R plus small r. The current I is equal to E over R plus R, which is now equal to 1.5 over 5 plus 1, which is now at 1.5 over 6. So the current I is 0.25 ampere. Now for the II, the potential difference across the 2 ohms resistor is V is equal to I multiplied by the resistor A. That is V is equal to 0.25 multiplied by 2. V is equal to 0.5 volts. Now, let me explain this. The potential difference V is the current multiplied by the resistor. But we are asked to find the potential difference across the 2 ohms resistor, which is the resistor A, as in the diagram. See, like in the diagram. This is the resistor A, but we have to find the potential difference across the 2 ohms resistor, which is the resistor A. So that is V is equal to the current I multiplied by the resistor A. That's it, multiplied by 2. Then now for the B part. For the B part now, it is when the resistors are connected in parallel. We have A, B. Here we have here the current that goes to A and the current that goes to B. Here we have the total current I. Here we have 2 ohms and 3 ohms. Here E is equal to 1.5 volts and internal resistance is equal to 1 ohm. So now for the external resistance, 1 over R is going to be 1 over RA plus 1 over RB. This 1 over R is equal to 1 over 2 plus 1 over 3, which is now what? The LCM is 6, 3 plus 2. 1 over R is 6 over 5 ohms, which is the same as 1.2 ohms. And the internal resistance, small r, is 1 ohm. That is that. For the I part now, I is equal to E over big R plus small r, which is now 1.5 over 1.2 plus 1, which is 1.5 over 2.2. So the current I is 0.68 amperes. Then now for the I part, we are looking for the current in the 2 ohms resistor. The current in the 2 ohms resistor. And then, yes, since the resistors are connected in parallel, the potential difference across A is the same as the potential difference across B, and is the same as the potential difference across the combination in parallel. That is, the potential difference across A is the same as the potential difference across B, and the same as the potential difference of the combination of the both VAB. That is, VAB is equal to IR, which is what? 0.68 multiplied by 1.2. So then VAB is equal to 0.816 volts. Now, for the current in the 2 ohms resistor, IA, is what? The VA over RA. So then now, the IA is equal to 0.816 over 2. That is the resistor of the 2 ohms resistor. 2 ohms is now what? 0.408 amperes. So this is the current in the 2 ohms resistor. And then I want you to note that current I is equal to the current that goes to A plus the current that goes to B. So the current that goes to B is the total current minus the current that goes to A, which is what? 0.68 minus 0.408, which is what? So the current that goes to B is 0.272 ampere. Now I want you to try this one. Two identical cells, each of EMF 2 volts and internal resistance 1 ohm, are connected together. The combination is connected to the external load of resistance 1.5 ohms. Calculate the current in the circuit if the cells are connected in a series and the second one parallel. So thank you. God bless. If you want to submit it to my private chat, so I will send you a link. Goodbye.